a competitive examination taken by a million students every year in India. This is from the February 2016 question paper. It's a question on the theory of computation. There is a problem, Gauge 2016, paper 1, question 17. Theory of computation, computer science information technology branch. It's a multiple choice question on decidability. There is a problem, question 17. We have got some decision problems and we have decided which one of them are undecidable. There are 1, 2, 3, 4 decision problems. First one says we are given NFAs, non-deterministic finite operators, N1 and N2. We have decided the language accepted by N1 and the language accepted by N2, which is the intersection of them, is identical. Another way of phrasing this is given two NFAs accepting some regular languages. Can we decide if the intersection of the two regular sets is empty? This means a distinct problem for the intersection of regular sets. Statement 2 says given a context-free grammar G with non-terminals, terminals, product and starting symbol, and we given a string in the language of all possible strings over the vocabulary, is the string X in the language generated by the grammar. This means a membership problem of context-free languages. Question 3 says, given context-free grammars G1 and G2, can we decide if the language generated by G1 equals language generated by G2? Now, context-free grammar generates the context-free languages. So, it's the equivalence problem of context-free languages. Statement 4, given a Turing machine M, is the language accepted by M equal to empty? That means that the Turing machine accepts nothing at all. We have a choice now A, B, C, D, depending upon a combination of 1, 2, 3, and 4. The multiple choice question, the examiner guarantees 3 answers are wrong and 1 answer is correct. In a multiple choice examination, we can assume that the examiner is very clever. He is ensured 1 answer is correct, 3 are wrong. We can follow 2 paths. We can guess the right answer and ignore the rest of the question, or guess the wrong answers and ignore the rest of the question. Both paths yield results to the problem. First, we will guess the correct answer, part 1. Let us consider statement 4. Given a Turing machine M, is the language accepted by M empty? Now, if I take an enumeration of all the Turing machines, only some Turing machines accept nothing. In other words, a non-trivial property of the RE sets. As only some Turing machines accept nothing, so it's undecidable. It should not be in the answer. It's also said to be the Turing is a question whether a Turing machine accepts something at all. This we know is undecidable. So case 4 is false, or case 4 is undecidable. Case 3. Given context-free grammars G1 and G2, are the language generated by them equal? The equivalence problem of context-free languages. We know the CFL's equivalence problem undecidable. That we cannot decide if a context-free language generates all strings of terminal vocabulary. So in other words, we cannot decide if LG1 equals sigma star, let alone if LG2 is context-free. So 3 should not be the answer. 3 is also undecidable. So 3 is undecidable, 4 is undecidable. So 3 and 4 should be in the answer. But we have to decide what are undecidable. So 3 and 4 should be in the answer. Now look at the choices A, B, C, and D. C says 3 and 4 only. In other words, C is going to be the answer. We need not read the rest of the question. Examiner has taken care that the question is consistent. So C is going to be correct. A, B, and D are going to be wrong. So C is going to be the answer. Let us guess the other part. If we guess the correct answer, we have got answer is C. Let us get the wrong choices now. Let us take one. If I have two NFAs, they accept only regular sets. So the intersection of two regular sets is empty. Practically everything about the regular sets is decidable. So this problem 1 is going to be decidable and cannot be in the answer. 1 is decidable. Practically everything about regular sets in NFA and DFA are decidable. Using De Morgan's theorem, we convert the intersection of two regular sets to union and complement. Now we know that the intersection of two NFAs is equivalent DFA. Emptiness problem is decidable for DFA created from the intersection of two DFA. So if I consider the NFA or DFA which comes from the intersection of these two NFAs, I consider all strings of length 0 to n. In a finite amount of time, we can decide if the intersection of two regular sets is empty or not. So 1 is decidable. 2. Given a context-free grammar G, I want the membership problem of context-free languages. This we can do by the cit algorithm, in which we can test the membership problem of context-free languages. Another way of stating it is 2 is decidable because the statement of the membership problem of CFS. One way is take cit algorithm. Other way is take all parsing techniques to back up. They also resolve the membership problem of CFS. So 1 and 2 are decidable. They cannot be in the answer. So A, B, and D. 1 should not be there, 2 should not be there, 2 should not be there. So A, B, and D can be ruled out. For elimination, C must be the answer. We need not even read the rest of the question or read what C is or whatever 3 and 4 are. This method of elimination is based on the IP equals pspace theorem of computational complexity. The examiner must have taken a great deal of effort in framing the question. So the method of elimination is very easy to get the answer. In other words, we say it may be in pspace to design the question. It's only interactive polynomial time complexity to get the answer. It's the famous IP equals pspace theorem applied to the method of elimination in multiple choice examinations. This method is applicable to all multiple choice examinations in any branch of knowledge. So the answer here is C. Under the presentation, thank you for your attention.